Alright, Chapter 4, Section 2, number 25. Skimming this one, we've got a sampling plan here for inspection. So let's look at this a little more closely. A manufacturer receives a certain component from a supplier in shipments of 100 units. 2 units in each shipment are selected at random and tested, and if either one of the units is defective, the shipment is rejected. Suppose a shipment has 5 defective units. So A, construct the probability distribution for the number X of defective units in such a sample. So the probability, the random variable, the discrete random variable X, we're looking there to find the probabilities for the values for the sampling here, and then find the probability that such a shipment will be accepted. So it's giving us a clue here, and that a tree diagram is helpful. Let's look at this first. So probability distribution for X. So we've got, let's see, 5 defective out of 100, because that's what the shipment is. Then we're going to sample 2. Alright, let's look at this. So we have 2, we're going to have 1, then we're going to check the next one. So that's where the tree diagram comes in first. So we can either have a defective unit or a good unit. So in the first sample, the probability of a defective is we've got a chance of 5 out of 100 that it's defective, right? And then 95 out of 100 it's going to be good. So that's for the first one. Then we look at the second one. If the first one was defective, then the probability of the second one defective is, so we're down to 4 because one was already defective, and that's out of 99. And the probability that is good is, let's see, so one was defective, so we're looking at the number of good is going to be 94, oh 95, let me back that one up there because that's not 95. I'm going to erase that because there's still 95 good ones out there in that process, right? Because we found one of the bad ones, so there are 95 good, so there's still 95 out of 99. And then if the first one happened to be good, then the defective, again, is out of 99. And this time, there's still 5 of those 99, because the first one was good. Or, for good, since we have there, we have 94 out of 99, because we had 100 there at first, but we found one of them, one of the good ones. So we only have, so instead of the 95 out of 100, we only have 94 possibilities left out of the 99 that remain. Okay, so for defective, probability of that would be 5 over 100 times 4 over 99, which gives us 0.902. Oh, no, it doesn't give that. What am I doing? So let's erase that one. So the probability of 2 defectives, that's what I have listed here. So defective and defective, that's going to be 0.002. So the probability that we have a defective and a good is going to be, let's see, we have the first one could be defective, which is the product of these two, or the first one could be good and the second one defective, so 95 over 100 times 5 over 99. And we multiply and add that out, so then we have 0.096. And the probability of good and good, that's going to be 95 over 100 plus 94 over 99. And that equals 0.902. So in other words, this equals the probability of 0. Let me back up. I have to erase again. I speak too fast each time there, don't I? So this is the probability out of the two bad ones, the probability that they're both bad. So the probability that we get two bad ones. And this is the probability that we get one defective. And this is the probability to get zero defective. Okay. So there's the probability distribution. So looking at the probability that it will be accepted, so it gets rejected if there's 1 or 2. So the probability is accepted is the probability that there's 0, which is 902. So again, we had to do this conditionally. So we had a first one, then based on what happened with the first one, we're looking at what happens with the second one. That's where we wound up with these slightly odd probability distributions. So we couldn't do the second one out of 100 as well, because we already knew the result of the first one. So it's dependent on the result of the first one.